All right. Good morning, everyone. Welcome back to Math 3. So I just wanted to have on the screen for just a minute or two a couple of notes, which I did send emails out about yesterday or 2 days ago. I can't remember. All the days are kind of melting into each other at this point, I feel like. And I'm sure I'm not alone. But I did send out a notification that we had an administrator changing some things around with everything being at home now. They wanted to just go ahead and combine test 2 part A and B as well as test 3 part A and B. However, I already had several students in my Math 3 classes that have taken part A of test 2, and I didn't want to have different assessments for different students. I didn't think that that would be fair. So the compromise is that test 2 will remain in a part A and part B format. However, test 3 will be combined. Now, I believe that I have set it up in your Connect shells that you can only see the part A and B for test 2. You should no longer be able to see the combined one. And then vice versa for test 3, if you go into chapter 3, if you haven't already, you should not see the part A and part B. You should only see the combined one at the end. So nothing changes with the homeworks, nothing changes with the quizzes. Remember that 3.1 and 3.2 were due the next class, so today, for today's lecture. And then 3.3 and 3.4 will be due next class, which if you are in my Tuesday, Thursday, that means it's due on the 7th. If you are in my Monday, Wednesday, that means it's due on the 8th. All right, so with that being said, this 3.3, this is 3.3. Let's get into 3.3. So we started talking about signed numbers last class in 3.2. In 3.1, we did exponents, which we've really seen before, just kind of a review, but we did a long review on it, and then square roots. And then 3.2, we talked about how a number can have a sign. So positive numbers on a number line lie to the right, negatives lie to the left. Now what we want to get into, just like chapters 1 and 2, we introduce something and then tell us how to do the math with it. So we introduce signed numbers, so now we want to know how to add, subtract, multiply, and divide them, as well as maybe some other stuff down the line. So adding signed numbers, it can be visualized on a number line, and I'm only going to do 1 or 2 of these examples because I'm not a big fan of this method because it's not really going to do you any good when you're dealing with double and triple and maybe even quadruple digit numbers, because it involves you putting a little dot where the first number is and then moving right based on the second number. If you're adding a positive number. If you're adding a negative number, that means you'd move left. And if you're supposed to add 2019, that means you'd move right 2019 times, and it just gets tedious and not really worth moving a dot right 2019 times. But again, addition of numbers can be visualized on a number line. Locate the first number, and then if the second number, if you're adding, is positive, then you'll move right. If the number you're adding is negative, then you'll move left. So with this 5 plus 4, the 5 will start here. So we start with the first number. This kind of feels like metric conversions, honestly. Plus 4, that says we're going to go right 4. So right 1, 2, 3, 4, and we end up at 9. So 5 plus 4 is 9, and that should not be any surprise. This is a problem we would have done before we even met each other, in my opinion. Negative 5 plus 4, now we would not have seen that up until today. So we start on the negative 5, which is over here. So we start with the first number, and then the next thing tells us how to move. So because that's a plus 4, we move to the right 4. If it said plus negative 4, then we would move to the, you guessed it, left 4. So right 4, 1, 2, 3, 4, and we end up at negative 1. So when we're adding a positive number, we go right. Now, unfortunately, I need to clear my screen. Give you a few more seconds. Okay. All right, so 5 plus 4 was 9. I'll put that back up. 1, 2, 3, 4. And then the negative 5 plus 4, 1, 2, 3, 4, was the negative 1. Negative 5 plus 5, so again, we start with the first number. We start on the first number. Now, because we're adding a negative, that says we have to go left instead. 1, 2, 3, 4, 5 times, and that puts us at negative 10. Or negative 5 plus 5. That says we're starting at the negative 5, which is here. And we're adding a positive, so we go right. So we go right 1, 2, 3, 4, 5 times. And we end up at 0. These are what we call opposites, as we talked about in next class. And it turns out when you add opposites, you always get 0. It's a very useful fact. So again, I don't really like this method going forward because we're not just going to be adding single-digit numbers. This will be very, very annoying to do with 2 or 3 or 4-digit numbers, as you can probably imagine. Right. So how should we actually go through this process? And I'm actually I'll show what they say, but then I'm gonna write it in my own words. I need to back out. There we go. Nope. Editing Word files is fun sometimes. There we go. So this table below summarizes the rules and procedures for adding integers. And the word integers honestly doesn't need to be said. This is addition of anything. Rationals, wholes, integers, irrationals, it doesn't matter. So adding numbers with the same sign to add, sorry about that. To add 2 numbers with the same signs, you add their absolute values and apply the common sign. That's okay. But here's the way I like to say this. If the numbers have the same sign, add the numbers and keep the sign. And I'm going to go back in all caps a few words. Same sign, then we add the numbers, oops, and we keep the sign. So I'm taking out the stuff about absolute values. I'm changing the phrase common sign to keep the sign, just to make it a little simpler. So when I say add the numbers, I mean, if they're both negatives, just add the non-negative part of it. So if you have negative 3 plus negative 5, I'm just saying to add the 3 and the 5 and then keep the negative sign with it. This is what will always end up happening. So when you're adding numbers, so if you have a plus sign between 2 numbers, if they have the same sign, you add them and keep the sign. The second version of this rule, adding numbers with different signs, says to add 2 numbers with different signs, subtract the smaller absolute value from the larger absolute value. What this really means is just think about the numbers without any signs up there and do the subtraction as you would have had to have in the past, the larger minus the smaller, because we can't take a smaller number and subtract a larger without considering signs. So again, what this means is ignore the signs, take the larger minus the smaller. That's how we can cut out all that absolute value jazz. Then apply the sign of the number having the larger absolute value. In other words, keep the larger number sign. But again, when I say the larger, I mean ignoring the signs. So if the numbers have opposite signs, I'm sorry, different, let me use the word different. Different and opposite mean the same thing here, but this word is a little better because of the letter it starts with, as we'll see. So if the numbers have different signs, you will subtract the numbers. And again, larger minus smaller in terms of what you would have known how to do before today. And keep the sign of the larger number. And I have the larger in quotes because, again, we're ignoring the original signs when I say larger. Because like -5 versus -4, technically -4 is larger, but I'm saying pretend the negatives aren't there, so 5 would be the larger number versus 4. So why have I all capsed a few of these words? Well, I've got a nice little mnemonic device to help with this. The rules for adding signed numbers can be made abbreviations. You may have heard of foiling, first, outer, inner, last. That's a factoring word that helps You may have heard of SOHCAHTOA for trigonometry. You probably haven't, but that's another one. But there's a few of these things out there. So what I have is SAK and DSL. SAK and DSL. Do you have to use these abbreviations? No. Do I find that it helps some students? Yes, a lot of students really love abbreviations. A lot of students really love mnemonic devices that help us remember how to do things. They don't necessarily have a reason in our heads. So SAK stands for same, add, keep. If the numbers have the same sign, you add the numbers in absolute and keep the sign. DSL stands for different signs. Then you're going to subtract the numbers, again, larger minus smaller, ignoring all original signs, and keep the larger sign. And by larger, I don't mean the one you wrote bigger. I mean, when you think about it in absolutes, whichever one had the larger number, that's the one you'll take the sign of. So again, I am a huge fan of how I have things phrased. Do you have to do it that way? No, there's a million ways to phrase just about anything. Same sign, add the numbers, keep the sign. Same sign, add the numbers, keep the sign. Same sign, add the numbers, keep the sign. I'm a fan of repetition myself. Different sign, subtract the numbers, keep the sign of the larger. Different, subtract, sign of the larger. Different, subtract, sign of the larger. Okay. So let's try out a few of these. Add the numbers with the same signs. They're spoiling things a little bit here, but it is what it is, right? So 85 plus 11. That's a positive 85 and a positive 11. So this is going to be SAK. Same, add, keep. And 85 plus 11 is going to be 96. And those are both positive numbers. 85 is positive, 11 is positive. So 96 is the answer. We keep the sign positive. That's all we have to do. Negative 19 plus negative 27. Well, this is once again, same signs. So we're going to add the numbers and keep the sign. So when I say add the numbers, you're just pretending like the 19 is adding 27. So we're just pretending we have 19 plus 27, and that would be 46. So I'm initially going to write a 46 here. Initially, I'm not saying that's the final answer. I'm saying all I've done is the 19 plus the 27 to get 46. But then we're supposed to keep the sign of the numbers we originally had. That was negative, that was negative. So this is a negative 46. Next up we have C, which once again, they're doing things a little too easy in terms of order here. Negative 127 and negative 58, those have the same signs, and we're adding them. So same sign, add the numbers, keep the sign. Same signs, negative, negative. So we add the 127 and the 58. So 127 plus 58, 7 and 8 is 15, 2, 5, and 1 is 8. So that's going to be negative. I'm sorry, let's just say 185 for now. I spoiled that, didn't I? So the 127 plus the 58 is 185. But we're supposed to keep the signs of the original numbers. These were both negatives. So we make that a negative 185. For 39 plus 76, once again, that's a positive 39 and a positive 76. So those are the same signs. So we're going to add and keep the signs. 9 plus 6 is 15. 3, 7, and 1 is 11. So that should be 115. And we're supposed to keep the sign of the original numbers. 39 is positive, 76 is positive. So that's a positive 115. That's all it is. I'm going to copy paste these rules and just plop them here so we can still see that on the screen when we do the next set of examples. If the numbers have the same sign, you add the numbers and keep the sign. If the numbers have different signs, you subtract the numbers and keep the sign of the larger. This is for addition of signed numbers. There has to be a plus sign between the numbers. If this was a subtraction of signed numbers, well, spoilers, that'll be in 3.4 today. All right. So same sign, add, keep the sign, different sign, subtract, keep the sign of the larger. Well, number 3, the instructions spoil a lot of things. Don't worry, when we get to 4, we'll be mixing and matching. So 81 plus negative 42, that's positive 81 and that's negative 42. So these have different signs. So we will subtract the numbers in absolutes and keep the sign of the larger number. Equals. Well, 81 plus negative 42. Okay, which one's larger? And again, I'm not thinking about the signs of the numbers. I'm just thinking about 81 and 42. Well, 81's bigger than 42. So that's the order of the subtraction we're going to do. And 81 minus 42 is 39. So they were different signs, so we subtracted the numbers. But now we got to keep the sign of the larger number. And again, when I say larger, I'm thinking in absolutes. I'm just thinking 81 versus 42. 81's bigger, 81's positive, so that is a positive 39 is the answer. Next up, we have negative 208 plus 136. Again, negative 208 plus 136. So these are different signs. The 208's negative, the 136 is positive. So since they're different signs, we will subtract and keep the sign of the larger. Now again, when I say subtract, I mean it's not necessarily the first minus the second. It's not necessarily the second minus the first. Ignore the signs, take the larger minus the smaller. It's kind of like when we were doing percent change, in fact. Hold on for a second. Sorry, I had a cough and I didn't want to blow your ears out. So we're going to subtract the 208 and the 136. All right, 8 minus 6 is 2, and then 20 minus 13 is 7, so that'll be 72. But then we have to keep the sign of the larger number. Now again, larger in absolute. We're ignoring the signs of the original values. So we're thinking about 208 versus 136, which makes the 208 the, quote, bigger number, but it's negative, and that makes the negative 72 the answer. That makes negative 72 the answer. Okay, 93 plus negative 213. Well, given the instructions, it's no surprise that these are opposite in sign. So this will be DSL again. So these are different signs, positive 93, negative 213. It doesn't matter the order of which one's positive and which one's negative. And I feel like that's something that there's some elementary schools that try and teach that it'll matter which one's first and second, and it's completely wrong. It doesn't matter. Sorry, just adjusting some things. There we go. So different signs, positive and negative, so we'll subtract. We take the larger minus the smaller, ignoring the original signs. So again, technically 93 is bigger, but ignoring that negative, 213 is bigger. So we're going to do 213 minus 93. Well, 3 minus 3 is 0. And then 21 minus 9 is 12. So that's going to be 120. That could be positive, could be negative. Haven't said yet. We're supposed to keep the sign of the larger number. 213 is, quote, larger in absolute. That's, again, ignoring the signs. So we take its sign, which is negative. So that's going to be a negative 120. Finally, we got D, 567 plus negative 184. Different signs, positive and negative, so DSL once again. So we're going to subtract the numbers in absolutes, larger minus smaller. 567 minus 184. So 7 minus 4 is 3. 16 minus 8 is going to be 8. 4 minus 1 is going to be 3, so 383. Please show that work to the side vertically if you have to. Remember, technically, this is a no calculator section, even though we're not enforcing that for the test anymore. But you should be capable of doing this without a calculator, because moving forward, you could be put in classes where calculators are not allowed. This is a skill that you are supposed to have embedded. This is not a skill the calculator does for you. Otherwise, why would we teach this? We would just say, use a calculator. Okay, so 567 minus 184 is 383. But now we say, all right, well, what sign is this supposed to be? Don't forget to do that. A lot of people forget to account for the sign. Well, we're supposed to take the sign of the larger number in absolute, so we ignore the negative. 567 is bigger than 184. 567 is positive, so this is positive. All right. Let's do some more. And we are not going to do all of A through F. We'll just do the ones we do. So simplify. Thankfully, they no longer tell you exactly what's going to happen here. So negative 219 plus 219. So that's a negative 219 and a positive 219, so that would be DSL. Different, subtract, keep the sign of the larger. So we're supposed to subtract the larger minus the smaller, and when you ignore the negatives, 219 and 219, they're the same. So which order do we subtract? Well, if they're the same, it doesn't matter. 219 minus 219 is, drum roll, no surprise, I hope, 0. 0 is a signless number, so I don't even have to worry about the sign of the larger. They're the same. There is no larger. They're the same. Positive 0 is negative 0 is 0. We'll do B next. And I like these problems because they start throwing multiple additions at you. So you've got to be on your toes. So let's just focus on the 4 plus the negative 18 first. The 4 plus the negative 18. I wish I could just highlight those two, but all we're focusing on for now is the 4 plus the negative 18. So if the 4 plus the negative 18, that's going to be positive 4 and negative 18, which makes them different signs. So we'll subtract them and keep the sign of the larger. So different signs, subtract. 18 minus 4, 18 is the bigger number in absolute. 18 minus 4 is going to be 14. So the difference of 18 and 4 is 14, but we're supposed to keep the sign of the larger number. 4 is definitely smaller than 18. The 18 is negative, so that makes that a negative 14. Then let's bring down the rest. Plus 24 plus parentheses 61. Honestly, that 61 does not need to be in parentheses because it's positive. You only need parentheses around negative numbers if it's a single number. So now let's focus on the negative 14 plus the 24. Negative 14 plus 24 is once again different signs. Again, I'm just focusing on this. I'm leaving the 61 out of it. Negative 14 plus 24, that's a negative and a positive, different signs. So we'll subtract and keep the sign of the larger. Actually, let me go one line lower. So 24 minus 14, that's a subtraction, and that'll be 10. And then we keep the sign of the larger number. Well, 24 is bigger than 14. The 24 is positive, so that's a positive 10. Plus, I'm going to remove the parentheses. As I said, we don't need parentheses around positive numbers. It's kind of pointless. So for 10 plus 61, that's a positive 10 and a positive 61. That would be, we haven't seen it in a minute, SAK. Same sign, so we'll add the numbers and keep the sign. And a lot of you probably wouldn't even, sorry about that. A lot of you wouldn't even think about this rule because positive 10 and 61, we would have been able to do that before today. It's 71. Well, the rule still works. Add the numbers, same sign, add the numbers, 10 and 61 is 71, then keep the sign, positive, positive, so positive. All right, let's do C next. C next. All right. So again, just focusing on the first pair of numbers, just 2 at a time. So 4 plus the negative 46. Well, 4 is positive, the 46 is negative, so that's DSL. Different, subtract to keep the sign of the larger. Subtracting the larger minus the smaller, ignoring signs, let's say 46 minus 4, and that's going to be 42. But, we're supposed to keep the sign of the larger. 46 is larger than 4, so that's a negative 42. Then our plus 37 plus our parentheses negative 25, and that parentheses is necessary. Now we're only going to focus on the negative 47, excuse me, the negative 42 plus 37. Well, 42 is negative, the 37 is positive, so that's DSL again. Different, subtract, keep the sign of the larger. So equals. Ignoring the negative for the 42, we do 42 minus 37, which is 5. But we're supposed to keep the sign of the larger. 42 is larger, so that's negative 5. Then we bring down the plus, negative 25. Alrighty. Well, negative 5 and negative 25 are both negative, so that's the same sign. So we'll add and keep the sign. 5 plus 25 is going to give us 30. So that's adding the numbers. But then we're supposed to keep the sign, negative, negative. So that's negative 30. And that would be our answer. Let's do one more of these. Let's do, see, B and C kind of had the same pattern of different, same. So let's do D next because that pattern is not going to be the same pattern. E and F are fun as well. You can try them on your own. Let's see. It looks like the answer to E would be 1. The negative 8 plus 52, that'd be 44. Then plus the negative 24 would be 20. Then plus the negative 19 would be 1. Yes, so if you want to try out E on your own, you should be able to get positive 1 as the answer. If you want to try out F on your own, 9 and negative 24, add to negative 15. Plus 47 is 32, plus 11 is 43, plus negative 30 would be positive 13. So those are the answers. You can try them on your own if you like. All right, D. Excuse me. There we go. Just taking a minute to, what's happening? Why is it making 2 equals when I hit it once? I don't know why it's doing that. Okay, that's really, really odd. Either way. So we got the negative 9 plus the negative 34. That would be same sign, so we'll add and keep the signs. Again, the negative 9 plus the negative 34 is same, so we'll add and keep. So 9 plus 34 is 43, but they're the same sign, so that makes it negative 43. Then we bring down the plus 43. These are different signs, so we'll subtract and keep the sign of the larger. Negative 43 and positive 43. And we've seen a problem like this earlier today. We saw that when we added opposites, like in 4a, they canceled each other out. They made 0. That's still the same. 43 minus 43 is 0, which is a signless number. Again, the answer to E would be positive 1. The answer to F would be 13. Try those on your own if you like. All right, let's do 2 more problems. Let me clear my screen. And then we'll move on to the next section. And it involves these translations. All right. Every now and then we're going to have to translate words into math. No surprise. So you're going to have to know that the words sum or increased or added to all mean, well, to add, to make a plus sign between the two numbers. So let's do A and B. Actually, I take that back. Let's do A and C. I'll give you the answer to B. The answer to B is negative 13. Try that out if you want to on your own. Again, the answer to B is negative 13. So the sum of 39 and negative 71 means 39 plus parentheses negative 71. That's what sum means. And then you use your rules. 39 is positive, 71 is negative, so they're different, which means we'll subtract and keep the sign of the larger. Let's see, 71 minus 39, that's 11 minus 9 is 2, 6 minus 3 is 3, so that's 32. So that's just the difference of the 71 and the 39. Then we're supposed to keep the sign of the larger. Well, the 71 was larger than 39. It was negative, so that's a negative 32. Once again, the answer to C is negative 13, because you'll be adding negative 28 and 15. All right, C, 134 added to the sum of negative 61 and negative 56. Added to means plus, sum means plus, so that's 134 plus negative 61 plus negative 56. All right, so only gonna focus on the first pair of numbers, the 134 and the negative 61 being added. Those have opposite signs or different signs. Again, opposite and different mean the same thing. Different signs, so subtract and keep the sign of the larger. The reason I like the word different versus opposite is because DSL is a type of internet. So it's just a better mnemonic device to me. Same with SAK, Sak. I mean, it doesn't have the C, but it still makes a word that is, memorable. Okay, so we're going to do 134 minus 61 because 134 is bigger. 4 minus 1 is 3, and then 13 minus 6 is 7. So that's going to give us 73. I got to switch back to this. So again, 134 minus 61 would be 73. But we're supposed to keep the sign of the larger. 134 is larger, it's positive, so the 73 is positive. And then we have our plus negative 56. 73 is positive, the 56 is negative. So once again, that is DSL, different, subtract, keep the sign of the larger. 73 is bigger than 56, again, ignoring the signs. So we're going to do 73 minus 56. Well, 13 minus 6 is going to be 7. Then 6 minus 5 is 1. So that's going to be 17. Then we keep the sign of the larger. 73 is larger. 73 is positive. So that is a positive 17. And that's it. So that is addition of signed numbers, addition of signed numbers. I'm going to copy paste these rules one more time. And again, this is for addition only with 2,000 exclamation marks behind it. If the numbers have the same sign, you add the numbers and keep the sign. If the numbers have different signs, aka opposite signs, but I like the word different better for this. The funny thing is I'll use the word opposite for another rule later because I like the letter O more in that case. Then you subtract the numbers, again, air quote, in absolutes, just ignore the signs initially, but then you'll keep the sign of the what you called larger number. SAK and DSL, what does this work for? Multiplication? Nope. Division? Nope. Subtraction? Kind of, but we'll have to do something first, and that's what we're getting ready to get into. But these rules only work technically speaking, when there's a plus sign between them. Now, moving forward, admittedly, a lot of people will not have the plus sign between them, and they'll still be able to use these rules just by practicing this tens or hundreds or thousands of times. But on a technical level, this rule only works for addition. Okay. So that is 3.3. Let us move on to 3.4. Subtracting sign numbers. And once again, they introduced the section with the concept of moving around on a number line. And subtraction is the opposite of addition. So normally subtracting a positive number, that says you move left, and subtracting a negative number means you move right, because adding a positive means you moved right. So now subtracting means you move left. When we added a negative number, we moved left, so subtracting it moves it right. Again, everything here is flip-flopped. You still start on the first number, but if you are subtracting a negative number, that's the opposite of adding a negative number. Again, I'm not going to focus on that. In fact, I'm not going to do any problems that way. I'm going to focus more on this idea right here. Subtraction of integers is defined in terms of the addition process. Addition is the same thing as subtraction, asterisks. They're in the same category there. It's why when we talk about PEMDAS, another one of those mnemonic devices, like foiling or Sak or Dsl or SOHCAHTOA for those trig students or future trig students. The reason we do addition and subtraction in the same step is because, quite honestly, in terms of math, they're pretty much the same thing. It's just subtraction is adding a negative. That's all it is. Subtraction is the same thing as adding the opposite of what you originally see. So 9 minus 6 is the same thing as saying 9 plus negative 6. Again, 9 minus 6 is the same thing as 9 plus negative 6. That's what the word equivalent means, same. And then they show that math here. So 9 plus negative 6, you'd start at the 9 and you would have moved left 6. Or if you do 9 minus 6, you start at the 9. Subtraction means you move the opposite direction as to what you think. Positive 6, you think it's right. So no, you go left. And you end up at 3 either way. So I want to write a few more examples. Where can I do this? So having, I don't know, 5 minus 12, that's the same thing as saying 5 plus negative 12. Or having 13 minus negative 11, that's the same thing as taking 13 plus positive 11. Subtracting a number is the same thing as adding the opposite of the original number. We don't change the sign of the first thing. See, the 5 stayed a 5, the 13 stays a 13. It's the second number that changes. We change a subtraction symbol to an addition symbol. And then the number after it, this was originally a positive 12, we change to a negative 12. Or 13 minus negative 11, so we change this subtraction. Sorry, it won't let me highlight just what I want. There we go. We change it to an addition. And then this negative 11 changes signs to a positive 11. So again, what we are doing is changing the subtraction to an addition, then change the sign of the number that was after the subtraction. That's the same thing as what says down here. To subtract two integers, add the opposite of the second number to the first number. I'm just being a little more specific. And then they write it with nice fancy variables. A minus b is a plus negative b. They honestly don't show both versions like I had, so I want to do that. A minus negative b would be a plus b, because the subtraction turns into an addition and the negative b turns into a positive b. A lot of people like to say two wrongs make a right, that these two negatives cancel each other out. And that is true. That's actually a rule for multiplication, which we will, guess what, see next time. So again, I'm not going to do this number line stuff for subtraction at all. We already saw we're going to get into 2 and 3 digit numbers. This would be a big pain in the butt to do that way. Let's just get down to the rules. And this is the textbook's version of it. And I really don't like the fancy words minuend and subtrahend. I will admit I have never used them verbally in my entire life. So leave the first number unchanged. Change the subtraction sign to an addition sign, then add the opposite of the second number. Again, that says exactly what we just set up here. In fact, let me make this its own line. Let me highlight it to really emphasize. Change the subtraction to an addition, change the sign of the number that was after the subtraction. That's what these 3 steps say. Okay, so we had flat out rules for addition before. We should probably write the flat out rules for subtraction now. So to subtract signed numbers, guess what? We don't. You change it to an addition, then follow the rules for addition from 3.3, which I'm going to write one more time, the same copy paste from before, Sak and Dsl. That's why I said several times last time that these rules were only for addition. When we get to subtraction, we still end up using the same rules, but we have to change it to an addition first. So when we have to subtract signed numbers, what do? We change it to an addition. To change it to an addition, we turn the minus to a plus, and we change the sign of the number that was after it. Immediately after that, we just follow Sak and Dsl, in other words, the rules from the last section. That's it. That's this entire section's worth of notes, minus a couple of word associations. So let's try out problem 1. And we're not going to do all of these. Let's do A, B, C, and let's start with A, B, and C, and then I'll decide. I think I want to do F, though. So rewrite the subtraction problem as an equivalent addition problem, and I'm not going to be able to use the, well, I'll pull out my pen. It'll just be a little uglier. So we're going to rewrite each subtraction as an equivalent addition, and then we're going to simplify. Now, I will admit, moving forward in later math classes, this is something, the rewriting is something I never do in an Algebra 2 class or in a pre-calculus class or a calculus class, because we end up doing this 5 billion times, so everything just learns to become a little more natural. People learn that subtraction is the same as adding a negative, so this minus here basically just counts as a negative there. So people learn how to do DSL or Sak on the fly after having done this dozens and hundreds of times. All right, so we're going to rewrite the subtraction problem. And I know a lot of you are going to say, well, 17 minus 4 is 13. Why am I going to rewrite this? I could have done this before today's lecture. Yeah, you probably could have, at least I hope, but let's just follow the instructions and make sure this works. So we leave the 17 alone. We change the subtraction to an addition. Now this 4 was originally positive, so we're going to change it to a negative 4. And then we can use the Sak and Dsl rules. These are different signs, so we'll subtract and keep the sign of the larger. 17 is positive, 4 is negative. 17 minus 4 is 13. The larger number was the 17, which is positive, so that makes it a positive 13. You're not really supposed to write that positive sign. I'm just emphasizing it here for once. So that's how we do this rewriting stuff. And again, I know a lot of you don't feel like you would have needed to do that rewrite. And honestly, on a homework or a test problem, if you didn't have to and you get the answer right, that's perfectly fine. But for a problem like -9 minus 12, I'm going to argue you might need to do the rewrite. We leave the first number alone. We change the subtraction to an addition. Then the positive 12 becomes a negative 12. That's the rewrite. Now we can use our rules for addition. That's a negative and a negative, so this is SAK. Same, add, keep. The 9 plus the 12 would give us 21, but we're supposed to keep the sign of the numbers. That's a negative and a negative, so a negative 21. And again, my more advanced students might just recognize this minus 12 in their head as a plus negative 12. They'll say, oh, these are two negatives, same sign, add, keep the sign, and they'll get the negative 21. I don't care in the long run how many steps you're doing this with. I care that you can do this correctly. And unfortunately, way too many of our developmental students, way too many of our Algebra 2 students, way too many of our pre-calc students want to rely on our calculators to do this stuff, and that is awful. There's no reason that anyone should ever need a calculator for this. This is a skill that should be one of the first bricks in your house of algebra. All right, C, negative 52 minus negative 52. So we leave the first number alone. We change the subtraction to an addition. And then we change the sign of the second number, the number after the subtraction. So this negative 52 becomes a positive 52. Then we apply Sak or Dsl. Well, negative and positive, so that's DSL. These are opposites. Opposites always add to 0. That's the third time we've seen it today. I'm just going to skip E. I'll do D and F. The answer to E is 30, in case you're curious. D, 21 minus 37. We change our subtraction to an addition. We leave the first number alone. Now, this was originally a positive 37, so we change it to a negative 37. Positive 21 and negative 37 are different signs, so DSL. We're going to subtract the larger minus smaller in absolutes. That's 37 minus 21, which would be 16. But then we keep the sign of the larger number. We called 37 larger because we're not considering its sign. 37 is negative, so it's negative 16. We said E, the answer is 30. Figure that out on your own. F, leave the first number alone, negative 27. Change the subtraction to an addition. Now the number that came after the subtraction was negative 39, so now it's positive 39. DSL, this book really likes DSL. Negative 27, positive 39. So we'll subtract 39 minus 27 is 12. We keep the sign of the larger number. 39 is larger than 27, so that should be a positive 12 as our answer. Let's leave that up there for a few seconds. Okay. Scroll, scroll, scroll. They have a whole bunch of these. We will not do all of them. No surprise. Let me just stick with my pen for this. In fact, let me scroll down a little more. And give myself just a little space. There we go. So 7 minus 29. We got to rewrite this. That's a subtraction. So we are supposed to, and again, if you're not doing the rewrite, if you're getting the answers right, I don't care. That's awesome. As long as you're not using a calculator, as long as you understand how this process works. But since this is our first day, I'm going to be doing these rewrites. But if you have me in the next developmental class, you would not see me do these rewrites. If you have me with quantitative reasoning or pre-calc, you'll never see me do these rewrites again. So that's 7 plus, change the subtraction to an addition. Now that was a 29 originally, so we make this a negative 29. Positive 7, negative 29, DSL, different, subtract, keep the sign of the larger. 29 minus 7 is 22. 7's positive, 29's negative, 29's bigger, so this should be a negative 22. I cannot tell you how many people would give me an answer of positive 22 for this because they're not paying attention to their instructions. Negative 31 plus 25. Now this is an addition. There's no rewrite here. Don't rewrite additions. We can go ahead to our rule. That's a negative and a positive, so DSL. These are different. positive, negative. So we'll subtract 31 and 25. 31 minus 25 being 6. But then we keep the sign of the larger. 31's larger, it's negative, and that makes that a negative 6. C, negative 48 minus negative 48. We do need to do the rewrite because that's a subtraction. So that's going to be negative 48. Change the subtraction to an addition, then change the sign of the number after it. So this negative 48 at the end becomes a positive 48. This is adding opposites. Fourth time we've seen it. Adding opposites gives us 0. Now, a lot of people will jump to the conclusion, oh, negative 28 and a negative 28. With the rewrites, these are going to be opposites, and it's 0. Well, guess what? You're wrong. That answer is not 0. Don't rush. We got to do the rewrite first. So that's a subtraction. So we leave the first number alone. We change the subtraction to an addition. Now the number after it was a positive 28, so we change that to a negative 28. This does not look like C. C was a negative and a positive. This is a negative and a negative being added. This is not DSL. This is SAK. Same add keep. They're both negative, so that's the same sign. So we'll add 28 and 28, which gives us 56. But then we keep the sign. Well, that's negative, so they're both negative. Keep the sign of the numbers. E. Well, that's a subtraction, so we need to do the rewrite. Leave the first alone, 146, change it to a plus. Then we change the sign of the number after the subtraction, so that minus 193 becomes positive 193. A lot of you might not think you need to write the rule for this, and that's okay, but I will anyways. That's a positive and a positive, so it's SAK. Same add keep. Let's see, 6 plus 3 is going to be 9. 4 plus 9 is going to be 13. 1 plus 1 plus 1 is 3. So that's 339. That's a positive, so we keep the signs, so that's a positive 339. I'm going to skip G. I'll tell you what the answer would be, though. 19 minus 22 is negative 3, plus 45 is 42, minus 12 would be 30. I'm also going to skip F. That would be negative 83 plus 38, which is negative 45, and then negative 45 plus 20 would be negative 20. So fill in the work there on your own. We will do H. Negative 19 plus 30. So we're going to focus on 2 numbers at a time. We don't want to look at this whole thing because then it starts getting confusing. That's an addition. There's no rewrite to be done here. We can go ahead and say, well, that's a negative and a positive, so DSL. 30 minus 19 is 11. Out of 19 and 30, 30 is bigger. 30 is positive, so that's a positive 11. Then let's bring the rest of this down. So that's a plus negative 9, plus 1 minus 3. I'll switch my color. Oops. Now we'll focus on the 11 plus the negative 9, which again is an addition, so there's no rewrite necessary here. 11's positive, 9's negative, so that is once again, every time I say that I get Bernie Sanders stuck in my head. Hopefully you get the joke there. Once again, I'm asking for your math. 11 plus negative 9, DSL. 11 minus 9 is 2. The 11 is bigger than 9, 11's positive, so that should be a positive 2. Then plus the 1 minus the 3. Let's switch colors again. Only focusing on the first 2 numbers, the 2 plus the 1, that's an addition, so there's no rewrite. It's SAK. I think a lot of us wouldn't have need to have done that. 2 plus 1 is definitely 3. 3 minus 3, and a lot of you are going to go straight to saying that's 0. I'll do the rewrite for practice. That's 3 plus negative 3. Adding opposites gives us 0. I might need a little more room for I, so I'm just doing that. Negative 3 minus 8. Well, we got to do the rewrite. That's negative 3 plus negative 8. Change the subtraction to an addition, change the sign of positive 8 to negative 8. Then plus negative 19 plus 21. In fact, let me go ahead and change all the subtractions to additions. There's nothing that says we can't go ahead and do that. So this minus negative 14, I'm going to change to a plus positive 14. So I changed this subtraction and this subtraction. That's all I've done so far. Let me make my 19 a little prettier. My 9s are terrible in general, and they're even worse on this board. All right, so we're going to focus on the first pair of numbers, the negative 3 plus the negative 8, negative, negative, so that's SAK. 3 plus 8 is 11. Keep the sign, so negative 11. Bring everything else with us, so plus negative 19 plus 21 plus 14. Now we're going to focus on the first pair of numbers. That's still an addition, which is nice. No changing over there. Negative and a negative, so that's SAK again. 11 plus 19 is going to give us 30. They're negatives, so we keep the negative. So that'll be a negative 30. Let's switch to orange. Oops, not yet, not yet. Bring everything down, plus 21 plus 14. Now we'll focus on the first pair of numbers. The negative 30 plus the 21, that's DSL, negative and a positive. So we'll subtract the 30 and the 21. 30 minus 21 is 9, but we keep the sign of the larger. 30 is larger, it's negative, so that's a negative 9. Then the plus 14 gets brought down. Negative 9 plus 14, those are different signs, so DSL. Subtract the larger and the smaller. 14 is larger, 14 minus 9 is 5. And then we keep the sign of the larger number. 14 is larger again, it's positive. So the answer is positive 5. So again, you should be able to reproduce these on your own without guidance from me ultimately. I really rely on SAK and DSL, but if you don't, if you have your own method, then use your own method. However you say it, whatever works for you, as long as you're able to get the answers accurately every single time, that is what matters. I gotta clear my screen. Remember, these go up on YouTube. And by the way, I'm not seeing a lot of views on YouTube from this course. That kind of scares me, honestly. I really imagine that a lot of people would be going back to this stuff. So please remember that every single time I am uploading these videos in Canvas within like a half hour of doing the live recording. Okay. Some keywords. And we'll do, I think, A, B, C, and D here. No, I want to do E. I definitely want to do E. So a couple of phrases that are very, very important. Just like we had some and added to, all mean plus. All of these means to subtract. But some of these are backwards. A minus B means you do the first thing minus the second thing. 48 minus Y is 48 minus Y. The difference of A and B, like the difference of 34 and 8, says you do the first thing minus the second thing. The phrase decreased by, so N decreased by 4, you do the first thing minus the second thing. So all of these are the first thing minus the second. Let me change my color. So this is the first minus the second, first minus the second, first minus the second. So the phrase is minus, difference of, decreased by, that's the first minus the second. The phrase less than and subtracted from, these reverse the order of the subtraction. That is extremely important. That is what most students would make a mistake on versus anything else with this. Not just at this level, pre-calc students get these backwards. Calculus students get these backwards. So you have to remember this. 6 less than 20 is the second thing minus the first thing. It's not 6 minus 20, it's 20 minus 6. Subtract 9 from 11 is not 9 minus 11, it's 11 minus 9. It's the second minus the first. So these two are extremely critical in remembering that they are reversed. Again, this is very easy to forget. This is very easy to pass over, and it means it's very easy to get it wrong. All right, I don't have too much time left, and I do want to do at least one example from the next bit of stuff with order of operations. So I'm only going to do a couple of these. Let's do A, let's do B, and let's do D. I said I wanted to do E, but I'm not going to. The difference of 73 and 39. Difference of does not reverse the order. That's the second one. So that's 73 minus 39. And again, technically, you don't have to do the rewrite here, but let's just practice it anyways. That's 73 plus negative 39. DSL, 73 minus 39, which is exactly what it said to do originally, right? 13 minus 9 is 4, then 6 minus 3. Something looks wrong here. Oh, I know why. This is one of the problems that I have my workbook next to me and there's an error in that one. They did 73 minus 29. So 73 minus 39. So again, 13 minus 9 is going to give us 4. Then 6 minus 3 is 3. So 34 is the answer. B, subtract negative 7 from 24. So the words from and less than, those are the key indicators that we reverse things. So we're not going to go negative 7 minus 24. We're going to go 24 minus negative 7. This is reversed. Change it to an addition, so that's 24 plus. Change the sign of the number after, so the negative 7 becomes positive. Clearly that's same, add, keep. 24 and 7 makes 31. For D, we got 56 less than 28. Again, the phrase less than reverses. It's very easy to think it's 56 minus 28, but it's not. It's 28 minus 56. Let's change our subtraction to an addition. So 28 plus, then change the sign of the 56 to a negative. That's DSL. So we're going to subtract the numbers. 56 minus 28 is 28. Keep the sign of the larger. The 56 is larger, so that's a negative 28. All right. 5, 4, 3, 2, 1, clear. So we can scroll. All right. Give myself a little more room. Got 5 minutes. Order of operations. As a reminder, PEMDAS. It's about the 5 millionth time we've seen that together in class. Remember that there's only 4 steps. Parentheses, then exponents, then multiplication and division go together, then addition and subtraction go together. Let's do A. 3 minus 11 plus 14 minus negative 2. Well, we got to do a rewrite because of the subtraction here. So that'll be 3 plus negative 11 plus 14. And let's go ahead and rewrite this. You can rewrite all your subtractions in one fell swoop, or you can wait till they come up to play. I like to go ahead and handle them all at once. So that becomes a plus, and then this negative 2 becomes a positive 2. The 3 plus the negative 11, just focusing on these, that's DSL. different, subtract, keep the sign of the larger. 11 minus 3 is 8. The 11 is larger, it's negative, so that's a negative 8. Plus the 14 plus the 2. Now we'll just focus on the negative 8 plus the 14, which is once again DSL, negative and positive. So we'll subtract 14 minus 8 is 6. 14 is larger, it's positive, so that's a positive 6. Plus our 2. 6 plus 2, they're all positive, so that's SAK, which is 8. Again, a lot of people aren't even going to think about the rule for that. They just go straight to 8, and that's perfectly fine. Let's do B next. And I'm going to have to write a little smaller to cram all this in. Actually, I can just go back to this. Go. And this is going to be the last problem we have for the day. Let's go ahead and do all the rewrites. Any subtraction becomes an addition. So that's negative 14 plus a 17 plus a negative 21. The minus 8 becomes a plus negative 8. The minus negative 15 becomes a plus positive 15. Change the subtraction to an addition, opposite sign of the number after. Change the subtraction to an addition, opposite sign of the number after. Negative 14 plus 17, just focusing on those. DSL again. Like I said, this book really likes DSL. 17 minus 14 is 3. 17's larger, which is positive, so the 3 is positive. Plus the negative 21, plus the negative 8, plus the 15. Now we focus on the 3 plus negative 21. Once again, DSL. 21 minus 3 is going to give us 18. But 21's bigger in absolute. That has a negative sign, so it's negative 18. Bring down the plus negative 8. Bring down the plus 15. Focus on the first pair of numbers. Again, this is all addition. So PEMDAS isn't really at play here. Just wanted to remind us. Okay, that's SAK, negative and a negative. So we add the numbers, 18 and 8 make 26. They're both negative, so we keep the sign, negative 26. Then we add our 15. It's only one pair of numbers left. They're adding, they're different signs, so DSL. 26 is the larger. 26 minus 15 is 11. 26 was bigger, it's negative, so that's a negative 11. And there is our answer. So that will close out 3.4. We've covered all the different techniques. So next class when we come back, we'll work on 3.5 and 3.6. So 3.3 and 3.4 are due by midnight of your next class. And again, I said those dates at the beginning. For the Tuesday, Thursday, that puts us at April 7th. For the Monday, Wednesday, that puts us at April 8th. I hope you all have a good day. Work hard, please, please, please. I have seen a lot of people stop working altogether. I'm going to start sending emails out reminding us that we're supposed to be watching videos, that we're supposed to be working on this stuff. I don't want you all to fail this course. You may have seen some things about a new grading system for TCC. That's only for credit level classes. This is a developmental class. We are still on the pass-fail system with S's, R's, and U's. So nothing about this class changes with grading, so please understand that. All right, so have a good day, and we'll see you next time on the internet.